Hello everyone, and welcome to the Game Engineering Podcast. Today I am joined yet again by my friend Kacper Kenji Leśniak. This time we'll talk about his work on Providence, an upcoming game from Dynasty Studios. Sit back and enjoy the show. Let's start with brief overview of the Providence, a game by Dynasty Studio where you work at.
Yes. So Providence is an upcoming game. It's a survival on a loop, multiplayer, kinda extraction, third-person shooter. So I will break it down because the genre of the game is pretty wordy. So first and foremost, it's multiplayer. It's a game where you play as a team, but you also fight with other teams that are trying to achieve the same goal or other goals than your team. And the theme is sci-fi. So you and your friends are trailblazers, which are those kind of mercenaries who land on different sleep worlds. And sleep worlds are sort of like asteroids or small planets that are very volatile, that are being sucked on into a black hole. And you land on those sleep worlds and you try to extract as much as you can until the sleep world just explodes or is sucked into the black hole. And it's a first-person game, so you see your character. It's a shooter because you have weapons and you can shoot other players. And it has some survival elements as well. You need to stay alive on the planet. You have health, but you also have oxygen or other resources. We're not super sure on the names yet, but some other resources that you need to manage to effectively stay alive and then at the end of the session extract from the planet with some valuable loot. And you fight both creatures on the planet. You fight flora, you fight fauna, but you also fight flora, some angry plants. And you also fight other players who might be after the same loot that you are right now. So yeah, it's a bit complicated. There's few parts to the game, but I promise it all makes sense.
But in terms of the loop, it's an extraction shooter. So you have this active part where when you're on a timer and you need to do stuff on the planet, and you call them sleep words with the I, not double E. So it's not like cozy sleeping words, but with the sleep words. And then you have homesteads, right?
Yes, exactly. So it's similar to other extraction games. Escape from Tarkov, I think, is the most popular, where you have this very, very strong dichotomy between the active and passive part. And yeah, active is sleep worlds. It's 30 minutes, sometimes 10 minutes, maybe sometimes an hour, maybe even longer for some teams. Loop, where you always kind of start fresh by landing on a planet. And then we have a persistent part, which is homesteads. So homesteads are places where you do a bit of crafting, you upgrade your gear, you do a bit of a base building, you expand on your base, you maybe do a bit more of kind of free form cosmetic stuff, make your base look as pretty as possible. But the main core reason for homesteads is to push you forward, to give you stronger gear, to discover some new blueprints, all that jazz. And then after you prepared on the homestead, again, you embark on a different sleep world and you try to gather some new resources.
Yeah. And Kacper works as gameplay programmer on Providence, so focus more on the gameplay part. But starting from the little bit of design questions to get more the scope of the game. How do you see the multiplayer aspect of this game influencing the gameplay?
Yeah. So there are two parts, I think, to the multiplayer. There is your team, which is up to 4 people. You can play as a solo player as well, but probably you'll quickly find out that as a team you can do more stuff on the planets. on the sleep worlds. And the second part is the competitive part. Other teams are on the same sleep worlds, and they don't necessarily try to kill you. It's not a battle royale. It's not Fortnite or PUBG. Their job is to also get some loot, secure some loot, and leave with it. So it's really up to the community, up to the players, how this will play out. Maybe sometimes teams will just pass, notice each other and then go on their merry way. And sometimes they will just fight to the death because maybe they suspect that the other team has the valuable loot that you've been searching for the last half an hour. And the teams will be either created before the game. You embark with your friends, but the sleep world servers are pretty flexible, so you can land on an existing sleep world. So for example, maybe there's already a team of 2 players and you as a solo player will join them and help them along the way. It's not really a very strict time where you can join it and then the sleep world plays out and then you leave it. Sleep worlds are there for a couple of hours, and then when the players join the game, it's pretty much up to them.
Okay. It's also interesting that you have 2 aspects of multiplayer-ness in the Providence, because it's both the team play multiplayer where you group in teams, and you definitely can achieve more as a group of 4 people, for example, compared to 1 person. But also you have this multiplayer enemy style where you can encounter other groups of people. And yeah, probably it's also interesting, like what will happen if 4 people encounter 1 person, and on the other hand, like what will happen if the 1 person encounters 4 other people at the same time.
I think it really depends on how much time has already passed on Sleep World, right? Some people have been there, they already have a lot of loot, so they are really careful with what they do. They just want to go back to their base and leave and go to their homesteads. And some people will just join and be kind of like hunters, They will go full out, not really gather resources, just try to hunt other players and steal their loot. But we will have a lot of different mechanics to both balance this type of playstyle, I would say.
And when you're on the sleep world, you can either gather resources. Can you gather resources and like create weapons and things like the gear to upgrade your gear that will help you in the combat, or what's there to do on sleep worlds in general?
Yeah, so there is, it's still a bit TBD, I would say, but the main idea is that on homesteads you do slow progression of unlocking new weapons, unlocking new gear, getting some upgrades like specific abilities for your weapons, right? But then when you land on Sleep World, it's not really, you don't land with your full capabilities. On Sleep Worlds, we also have some sort of small, faster progression. And this is to kind of make players a bit more equal when they land on Sleep World. So a person who is, fully geared, played a lot, is not landing on Sleep World with much stronger capabilities than other players. You still can fight, as a player who just started the game, you can still fight a player who has spent 100 hours in this game. Of course, maybe the other player will have some more abilities, some more tools at their disposal, but they won't have 10,000 health compared to your 100 or something like that. So there is also this part of, let's say, normalization of players.
Okay. So so when we land there, we can either extract resources, fight the local enemies like the monsters there, right?
Yep.
Build bases, but that's only gonna last for the remaining time for the given sleep world,
yes.
Right? Okay.
Yes. So base building on Sleep World exists, but it's very much pragmatical. You just have a couple of blueprints of things like, stabilization field generator, which gives you some resources to survive on the planet, maybe a processor for the resources, maybe a regrowth chamber, which is like your additional respawn point. So only things that you can use at the moment, right? Like during the fight or for gathering resources, and all the actual buildings, progression, also just your player base, your walls, your sofa, your coffee table that you'll place at your base, all of this stuff is only available on homesteads.
Okay. And a large part of Providence is the procedural generation for all of the stuff. And I know you mentioned that you want to feature blockchain and things that will be generated and then stored for players to reference after, to be owned by the player. How does the blockchain aspects meld into this?
So Providence will be a Web3 game, which means that we will, in some ways, interact with blockchain, but kinda on the contrary to the general trends in the blockchain gaming space, where the whole point of the game is just blockchain side, the NFTs you can buy, the tokens that are distributed, all of that. We are more focused on the game. We are just making a good game, as a game that can be fully enjoyed without any interaction with blockchain. But blockchain is basically for us one of the layers that we use as part of monetization or player economy, right? Because at the end of the day, we'll mostly use it in the of course, part of the stuff that I'm talking about is still to be decided, but if you get a really nice item or a really cool skin for your character, when we have integrated blockchain, you really own it. You can sell it to other players, right? You can use it as an actual resource and maybe trade with other players for a different skin that you like. So it's not soul bound like in League of Legends, for example, or other games where skins are just a value in some database stored for your account.
Okay. And that's also nice. I think that might be the proper way to approach blockchain and things that players own, because if you make it the game, then you kind of lose the gameplay aspects of a game, right? And it would be nice for this to be like an addition. I remember like World of Warcraft market stuff when you kind of stopped playing the game and then started to mine resources and then go on the marketplace and trade them, and kind of inside the game you had like a different game that you need to do, like grind resources in order to progress further. So it's like it was like a clash of two gameplay sides. Okay, and I think
it's a whole genre of games, right? It's called play to earn games, which are not only blockchain games but also blockchain games, which one of the main reasons you play them is to just earn real world money. But this is not really our approach, right? Our approach is to make a really good game that is the core gameplay is fun, that people want to come back to and keep playing. And then one of the ways you can interact with the game is through the blockchain, and you can have your items, your skins, your upgrades, maybe your buildings in your base just stored in a slightly different way, which gives us more, which kind of boosts the player economy side of things.
And maybe let's mention at what stage Providence is currently as a game, as a project, so that we'll have like a proper lens, what can be changed, what will remain this as we talk about it.
We are very much in pre-alpha stage. We are still developing the game. We do have a core loop ready. We play the game internally a lot. We also featured the game in closed playtests on some conferences. recently, I think 1 or 2 weeks ago, there was a big conference in Istanbul, and people were able to play the game together. We had a closed playtest for some of our most active community members as well. And so we do have a game, but it's still at pre-alpha, right? We are still very much discovering the details, maybe changing even some bigger systems that we have. We are very much working on homestead and persistence and the whole progression part of game. And we don't have the release date yet. Probably next year, somewhere next year, we will enter into a more public playtest stage. But you will have to wait for more details on that, because we are still kind of deciding on at what stage we want to have players play the game, right? We don't want to be an early access game where you already have some things to buy and some skins for your characters, but the gameplay is completely lacking. We want to actually give players a thing that they can play and enjoy.
Okay. Shall we then dive more into the technical aspects of Providence?
Yes, let's do it.
What should we start with? Have any ideas?
Well, we're building the game on Unreal Engine, right? That's, I think, the most important aspect of it. We're using Unreal Engine 5, so the newest version of the engine, which comes with a lot of unique and exciting systems to use. And yeah, we have a strong mix of using their tools, but also some our internally developed systems.
Okay. So tell me more about the tools you use for the procedural generation. I was wondering how, because the idea is that sleep words will be in large part generated, so that you can't handcraft all of the stuff. So we need to have efficient tools for creating those, and but some of the aspects of sleep words have to be handcrafted, like made by hand, in order to make sense, right? So what's the strategy here?
Yeah, so I think there are two parts to it. One part is how you designed it and implement it, and the second part is how you actually handle it on the back end, right? How do you make systems that can handle big maps with many moving elements, with many interactive plants, resources, monsters, things like that, because just throwing in thousands and thousands of things on a map and then hitting play and hoping it will work, it probably won't work. So on the first aspect, we are using PCG tools from Unreal Engine 5. It's a very, very new system, so we are still learning it and exploring it. It's been released very recently. So when we were starting the game, we were using different tools. We were kind of exploring more handcrafted ways of building sleep worlds. But as we learned that Unreal Engine has this new very cool feature of PCG, it's called basically PCG graphs in Unreal. It doesn't have any fancy name. We very quickly started using it, and we plan to use it as much as we can. It's crazy. It's there is a very nice video of that features how it works and how to use it, which showcases like a forest map with some ancient ruins, and basically you just pick a brush, paint some stuff on the map, and it spawns different kinds of assets according to some very specific rule sets. So it looks really cool. Of course, deep down inside, it's pretty complicated, and we have some brilliant people working on it and defining those rules and deciding, how much can we spawn procedurally and how much should be kind of carefully designed points of interest, right? So, of course, if we have an important piece of terrain with some very rare resources, maybe a monster or a boss that's guarding them, it can't be really fully PCG'd, right? Because then it's gonna spawn some random things that won't be really fun to play with. So yeah, it's a mix.
When you say rules, what can you give me more examples how the rules look like?
Yeah, I'm not directly hands-on on PCG, but I've seen the graphs, and the rules can be whatever you like. It's just up to you to decide how much complex stuff you want to set in. So, for example, you can spawn big stones in some parts of terrain that maybe have a specific height, right? Maybe those stones are only on the slopes, let's say. And then you make a second rule, which is around those big stones, when you are in this kind of, let's say, biome, you spawn small trees, right, around those big stones. And then you have small flowers, and you say, okay, those flowers actually only grow next to those trees, but only on the side that's facing outwards from the stone, or, and all of this stuff. So it's basically, let's say that art makes a beautifully looking concept art, or maybe hand places some assets in the level, which gives you an idea of how the world should look like, right? And then you can sit down and actually code rules and nodes in the PCG graph that will do it automatically. And then you will be able to just paint on the map and spawn this type of complex structures, let's say, around the world.
Do you run into problems with performance? Because in my mind, if you have beautifully designed 3D model, then you hook it up in a PCG tool and then you spray all over your terrain, beautifully looking, very detailed models. You kind of quickly end up in the issue of, well, it's not rendering quick enough.
Yeah. Then again, Unreal 5 comes with a beautiful tool called Nanite, and Lumen as well. Those two systems are kind of intertwined. So Nanite is a way of virtualizing triangles, geometry on the meshes, which, just to give like a very short overview, if you have a super detailed rock with 5 million triangles, and we have some of those rocks in our game, you can actually use this rock. You don't have to make big changes to it. You just enable Nanite, do some stuff that I don't really know about that much, but you can put this rock in the level, and then when you play, Nanite will take those 5 million triangles and then virtualize them and kind of break it down into bigger chunks, and then automatically do LODs, so automatically do level of distance details. So if you will be close, maybe you will see more triangles and the rock will look way more high definition. And where you are far away, Nanite will automatically break it down into maybe just, 10 triangles, making a rough shape. And yeah.
So it's a way of automating level of detail based on the proximity to the player, things like that. Okay.
Exactly. Because before that, artists or programmers had to do it themselves, right? So you'd get an asset, and then you'd have to make, okay, if the player is closer than 100 meters, this asset should look like this. If player is closer than 50 meters, it should look like this. And it's just a pretty slow workflow, right? And many things can go wrong with it. But Nanite technically removes that problem. Of course, it's not perfect, right? Because you still have to have this huge rock in memory. So you can't just have, 1,000 different assets that are super high definition, constantly loaded, and then virtualized, because you will just run out of RAM or VRAM. Yeah.
But so by replacing these kind of problems, does it introduce another set of problems, or not really?
Yeah. It's a bit of a different. Like, there are some settings you need to watch out for, right? Like, after art imports an asset to the engine, they need to tick some boxes. Then you need to constantly kind of watch, like have somebody on the job of checking if we don't have an asset that's, for example, not working with nanite, right? Sometimes materials can cause problems with nanite, and then an asset suddenly stops using nanite, and then you have, one tree in the level that's using 90% of your GPU budget because it has 10 million triangles. And we had exactly the same, this thing happen, right? There was one tree that was causing all of our problems. And depending if you had this tree in your camera or not, you would get completely different performance.
Yeah, I always wonder, like, there are new tools, there are often new tools that help you and do like another set of layer of abstraction, but then you need to understand both the new layer of abstraction and the old layer in case something goes wrong. So I wonder what's the end result of your like effort that you need to put into, because you need to learn the tool and then you still need to be able to debug it and help if there is like a unique tree that will mess with your scene and things like that.
Yeah, exactly. And I think Unreal is a very good example for that, because Unreal comes with huge number of tools that are super complex and don't have really great documentations, that don't have great tutorials. When you search for tutorials for Unreal Engine, you pretty much get tutorials for beginners. And if you start diving deeper, you will get some scraps and tidbits from different blog posts or YouTube videos, and you will have to figure out a lot by yourself. Mostly by just reading the code base of Unreal or debugging it.
But that's also nice, because like if you're in Unity and you want to dive really deep, like after 3 jumps, let's say 3 like classes, 3 layers of abstraction, you kind of realize, oh, that's not available. It's closed source. It's an external function that is being loaded in, so I have no idea what happens under the hood. So at least you have a source code. Like, this is nice. But yeah, the Unreal Engine source code is huge enough that I don't think currently anybody has like an understanding of all of the Unreal Engine source
code. Definitely not. You can be an expert in Unreal Engine and literally know 5% of it, right? Because it's just so vast.
Yeah. Okay. I think we want to also talk about mass and the subsystems of Unreal Engine. Tell me about them.
Yeah, so mass is actually the second part of I was talking about, right? So first part was how do you actually show it to player and build it with how do you build it with PCG tools? But then you also have a problem of how do you just keep up with all the things that get spawned in the world, not from the GPU perspective, not from the rendering perspective, but from CPU perspective. So if you just throw them in as objects, like normal objects or actors in Unreal, you will quickly run into some problems. If you have 50,000 trees and each tree is a separate thing, whenever you will try to do something with the tree, maybe if the tree just gonna be there, maybe that's fine, right? But if you will try to maybe update the tree state based on some sort of condition, maybe there's a storm and we want the trees to go into a state of losing leaves, something like that, or maybe a monster is corrupting the trees and changing how they look like, you will very quickly run into problems with CPU, because how the CPU caching is handled. Every time you update a tree, if you want to update 1,000 trees, you'd have to pick one tree from the memory, find it, update it, put it back into memory, take a different tree, which is in a completely different place in memory, update it, and put it back, right? And that's where mass comes with all its glory, it's basically an entity component system that's very friendly for CPU cache, and it kind of makes it more difficult to work, like from programming perspective, with certain behaviors and entities. But on the other hand, it's very well separated. It makes you very kind of rigid. You need to do things in a very specific way, which at the end will turn out to be way more effective and way more performant, right?
Yeah.
So yeah, and we use mass basically for all of our resources, right? For all the trees, plants, stones, everything that you can interact with the world, underneath is handled by mass.
Yeah. It's also maybe useful to note that if you have a cache, you don't control what's in the cache. So when you load a variable that is not in the cache, there are three layers of caches in CPU: L1, L2, and L3. Some of them are shared between cores. Some of them are just specific to a core. So in order to, if you load a variable which is like 4 bytes, for example, there will be more memory loaded with this variable. So the immediate next bytes will be loaded as well. And if you then load anything after that, and it's already in cache, you get like 100 times or 1,000 times if it's L1 cache boost in the time of just retrieving this data, right? Because it's already near the CPU. And usually if you have a Unity game objects or Unreal actors, if it's all separated, then one seemingly, let's say, a small object is actually having ton of bytes, because it has like physics variables, or it's like position, rotation, scaling, all of that occupy this. So if you want to loop over, for example, 10 or 10,000 objects and update just the physics of them, and just one variable, velocity, for example, you will need to, if you manage to pack the data so that the velocity variables will be near each other, it will be all loaded into the cache. So I think that's the system that uses this, and usually, I think game engines also call this entity component systems, right? Right?
Yes. Yeah. Exactly.
Yeah. So it's like it will, and it influences. How does this exactly influence the programming part of things in Unreal?
Yeah. So it separates completely variables and components, let's say, on those. Well, okay. So it separates entities and components on them from the behaviors that you want to run on them. So if you program normally, let's say, you would have a class. In this class, you would have some variables, right? And then you would have a function, maybe on tick, on update, or on whatever else you want to. You would update those values based on those values, do something else, right? In entity component system, you have entity, which is a kind of like a bag of components. So let's say that our tree that I was using as an example has a component for how it looks like visualization. It has a component for its state, like flora state, let's say. And then it has a component for collisions, for example. Or I think it's part of visualization in Unreal, but let's say like this. And then when you want to do any behavior on this, it needs to kind of come from out of the entity, right? Because now you don't have a whole tree class with very specific variables, very specific behaviors. You just have components, and then you have, in Unreal, it's called processors that run on those specific components, right? So for example, let's say we have a monster running around the world corrupting trees, right? Our worlds are big, so maybe there are 100 of those monsters corrupting thousands of trees. In the old way, or the usual way, you would have to, as you say, loop through all the trees that are around monsters, pick every one of them from memory, waste a lot of cache, and then do some logic on each of the specific trees. But in entity component system, what you do is you define a processor, and this processor only works on the trees that have, or not trees, it works on the entities that have a component flora state, and in this component, they have a state corrupted, right? So we define some sort of filters, and then the CPU will load all of those components to cache, and it will do a specific behavior on them, in a very, very fast way, because they are already in the cache. It will load the behavior to cache. It will load the entities, or not entities, their components pretty much to cache. And then you can, in an instant, do a even more complex operation on thousands of entities.
So you have to, you have to split the things into like the behavior and the things will be separate. Usually you would have,
yes,
by default you would have this closer, so it makes, let's say, more sense, but it's less friendly for the computation, right?
Yes, and it's less, but working with it is less friendly for the programmer, right? Because if we were doing it normally, I would say, this monster, get all trees in this radius, then call this function on those trees. Then you would have this function. You would go into a tree class. You would see this function. The function would be corrupt. And then in this function, you would have some sort of behavior, right? But now it turns more to this monster just adds a tag or a, component to those entities that are around them, right? It doesn't even know what entities are around them. It just adds a tag corrupted to those entities. And then somewhere in a different processor, you say, if I get all the entities that are Flora entities and have a tag corrupted, and then do some stuff on them. And maybe you won't be able to do a whole logic, right? Because maybe you only have access to Flora state. So maybe you'll just do some parts of the logic, maybe add another tag, and this another tag will be picked by another processor, which only works on the things that are visualized, have collision right now, and have this tag, and then do some other logic on them. So it becomes way more fragmented, I would say, and it's a bit more hard to understand what's going on and to debug it, right? Because it happens in a parallel. It's not like a monster calling a function on a tree, and then function in a tree gets the mesh from the tree and then changes the mesh, right? Its monster does something to the trees, and then at some other point in the future, the trees know that they have to do something, and then they will start doing what they have to do. So it's a bit of a more complex stuff to both develop and debug.
Yeah. Did you have the ability to see like how much more performant the mass version is versus the old version for your particular game, or not really?
Not really, because when we started developing, we were not having such densely populated worlds. We were working with pretty desolate worlds, and then our game developed into this thing where you land on a planet which is fully populated with a lot of stuff. So when we knew that we had to go that way, we were already using maths, right? And we won't switch the system for another just to compare performance, but I'm pretty sure it just wouldn't be possible, right? Without it.
Yeah. Okay, we talked about generating all of the entities. We talked about updating them and logic in general. And what about the networking aspects of Providence?
Yeah, so that's something that I actually work more hands-on. I did work on mass, but now pretty much my whole life for the last few months is networking and replication, and more in detail optimizing the servers so they can work fully with more than 20 players. And Unreal Engine has already built-in replication, so that's the easy part. In theory, it's just as easy as clicking replicate movement on an actor, and then it replicates the movement. And it's nice, it works, right? You can maybe build a small game with 3 players that are playing peer-to-peer and are walking around doing some stuff. That's fine. But when you start developing a bigger thing, all those things that Unreal does all right turn out to be too little for you. They are a bit too slow. They don't do exactly what you want to. They struggle with bigger number of players. They struggle with bigger worlds. And then you need to go yourself and learn first how it works under the hood, and then try to optimize the hell out of it and try to make it work, right, for your particular use case.
Yeah, that's like, again, these abstractions thing. Like, it's the more abstractions you have, it's nice as long as it works. But then if it doesn't work, you need to both learn how the abstraction works, and then all of the details of networking, and just like, well, it's a TCP, UDP, how big are the packets? What can we update here? Like, what is the like rate? What's possible? It's all of that doesn't go away. And it becomes like painfully visible if things stop working.
Yes, exactly. And it's really showing how unique it needs to be to fit your game. I think that's the biggest difference from, world of software engineering, where, we both worked as software engineers, and we know that there tends to be some sort of a way which is the correct way, right? Or, you can learn about specific methodologies or flows, or how to structure your class, how to make them work together, which are just good wherever you're working, right? So it doesn't really matter what the company is working on. This is probably a way that might work for pretty much majority of cases, right? But when it comes to, for example, networking, especially like in Unreal, there is no golden solution. Like, it depends so much on so small technicalities of your game, because you cannot afford to just replicate and send everything over the network, right? You just can't. So you need to very carefully decide, go through each part of your gameplay loop and decide, okay, this should happen only on the clients. This should happen on servers and send data to one client who is actually doing this. Oh, this thing should replicate the data to all the clients that are on the server. Oh, but maybe this thing doesn't need to replicate to all clients on the server. It needs to only replicate to clients that are 100 meters from this specific place on the map, right? And then you run into so many of small hoops that you need to analyze one by one and decide, okay, this is something that we need to actually include in our replication system, right? And we need to optimize it because that's how our game works. We really need to work on that. And you can't just, buy a library online which will do all those things for you, because it's just not possible.
Yeah, and it adds another layer of complexity to your whole game, right? If it was one single player, then you just work on the gameplay part, obviously design art, but like, after you make the same game multiplayer, now there's this like everything that you see, everything you have worked on previously now needs to be, let's say, at least there needs to be like a decision whether it's supposed to be replicated. Is it enough to be let's say replicated at the beginning of the game and then like rendered throughout the whole game, or just you need to update it? What kind of tools and solutions you've worked on for the networking for Providence? Like, what kind of problems of this part when you managed to solve?
Many. I think we don't have time today to talk about all of them. I think, maybe I can talk about few. One of the things was replicating the plans, right? The resources, everything that's on world to all of the players. And that's a thing that was not possible when we started working on the game. Like, not possible meaning that we tried to do it, we turned on replication of the things, and then it was just not working fast enough for our case, right? If you land on a planet and then suddenly the server needs to send you the data about 50,000 trees that are on this planet, it's not gonna be fun for you, right? And you're gonna see the trees just popping off and appearing out of nowhere because suddenly the server, decided to send you the packet for this tree, and it's not really available. And that's one thing, but also the thing about updating the trees. Unreal does it in a slightly weird way, which is not push based. So it's not the tree telling the replication system, I need to update my state. Its tree is updating its state, and then the replication system goes over all the trees, checks if their state has been updated, and if it has been updated, sends it back to the clients, right? And not only that, it also goes through each of the clients and checks whether this client is close enough that the change of the state of the tree should be sent to them, should be relevant for them. So then you end up with server every frame iterating over 100,000 actors 20 times, because you have 20 players on the server, just to check if you should update and send this specific data to the clients. And this is so that's the way that it works out of the box in Unreal, right? That's how the replication system works, and we had to do a lot of work to kind of reverse the whole idea. And
How much of the Unreal stuff you left in, and how much of it you needed to build yourself?
We left a lot. We are pretty much still using Unreal replication system, right? We didn't dive as deep as completely changing how the channels work, how the replication graph works. We just understood how it works, and knowing how our game looks like, fit it inside. So we decided what it is actually that we want to send over the network, and we want to check for on the server, that is so important. And our solution, also like very, very high level overview, is that instead of sending the trees and all the plants and stuff to clients, we only send updates. And deciding the update is a system that we developed that kinda assumes that the clients already have the tree there. So the baseline is that everybody has a full normal map that is generated by PCG with a specific seed, right? So everybody's on the same page in the beginning of the game. And then we very, very carefully select updates to the specific trees on the map. Which is, all right, somebody like a monster corrupted this specific 10 trees. We will send those actions to the clients that are close to those trees. And that is done by some sort of managers that are kind of flying around over the map and, watching over this part of the world. And those managers are like, okay, I'm taking care of this 1,000 trees. Whatever happens to them, I will send off to the players that are close to me. So those are kind of like beacons, you go, there's an invisible beacon, and this beacon knows what happened to the environment in this specific area. And then thanks to it, you don't have to go over all the trees. You just go, okay, for this beacon, this has changed. For this beacon, this manager, this has changed. And that enabled us to actually run the game, because before that, it was working, we had like 2 FPS on the server, which was completely not working.
And because now we mentioned FPS on the server, I think you mentioned this to me earlier also. Like this is also the metric you have for judging performance, right? Like
yes.
how fast server is operating, because then it's like you can then use this to know how performant the game is on the client side.
Yes and no. So the performance on the client is a different thing, right? You will still have your game running at 60 FPS locally, even if the server is running 2 FPS. But what it will do is that imagine server is running at 2 FPS, meaning that each update takes half a second for the server. That means that whatever you send to the server, before the server processes it, it will take half a second, or half a second to be precise. So then what it will do is you will have this artificial ping on top of your own ping. You will have this 300 millisecond ping that just comes from the fact that the server is very slow. And I don't know, you probably played with 300 ping or 400 or 500 ping. It's not really possible, right? You throw a physics object and then suddenly it jerks around to a completely different place, right? You use an ability and then the ability is used completely in other point of time.
Yeah, and then you mentioned a couple of times the things that are being replicated, they need to be close enough. Do you have, does this vary? This varies for different kinds of objects, or do you have like a...
Yes, definitely. If we have a giant tree in the world, we need to be able to see it from very far away. If we have a small monster, for example, this monster really needs to be replicated to a player if they are 50 meters from it, right? And this is also something that we do for server performance, maybe. The second biggest leap that we've done. We did a lot of small adjustments, right? Small upgrades to the system. But two biggest things were this managers for the world, for the trees and all the flora that's on the world. And then the second one is monster performance. So the performance of the AIs that are on the world. Because Unreal is not really good at having a lot of characters at the same time. And this is something that you will quickly, if you ever tinkered with Unreal, right? If you just put 100 zombie characters in a level and try to play the game, it will struggle a lot because the Unreal implementation of characters, especially humanoid characters, but also non-humanoid, like just things that move and play animation and have some sort of logic behind them, it's pretty slow. So that's the second thing that we did, is pick all the monsters and see what we actually need to do with them, right? And when do we actually need to do with them? So we have thousands of creatures on the world, right? But not all of the creatures are working at the same time. Not all of them are kind of awake at the time. If we have a big boss that needs to affect the world, of course, it will constantly in the background walk around, do some things, right? But all the smaller creatures, we try to be very smart with when do we actually run any logic of them. And that comes down to pretty much when the player is near them.
Okay. But when the player is near them in like a meter proximity thing, or do you have also like a structure, like a B tree, when you just divide all of the world into different pieces, like recursively, and to try to do this in this way?
So base Unreal implementation is just the distance. So base implementation is literally iterate over all actors, calculate the distance to the players, and see if the players are relevant for those creatures, right? The better way of doing it is something called replication graph, and this is also part of Unreal. This is what Fortnite uses, and but it's not working out of the box. You kind of have to enable it. You have to tune it to your game, do it in C++. It's not like a thing that you, like a plugin that you just enable, right? It's a bit more of a hassle, but that's exactly what you said. It's kind of like a grid that controls the world, and based on the players in the grid, it decides what should be relevant for who in a bit more optimized way than just iterating over everything and calculating the distances.
Also, now I realized the slip words are like an actual planet that if you go one way, can you do a full circle?
No, the Earth is flat in our game.
Because if that would be the case, all of the distances would not be the correct distances, right? Because you need the distance. It is okay.
No. please, no. No, because sleep worlds are not technically planets. They are asteroids, you know. So you can actually walk and see the edge of the sleep world and see like rocks flying from this edge and see the abyss of a space in front of you.
It's like a proper flat Earth confirmation theory. Like
yes.
Okay. Nice.
Exactly.
How do you approach testing this stuff?
Yeah. That's a hard topic. I maybe before we go into it, I just wanted to say, because I haven't really explained why I talk so much about CPU on the server, right? And I think a lot of people think that when it comes to network performance, you optimize bandwidth, right? You optimize how much things you send to clients and how much things clients send to you. But the truth is, unless you're doing something very wrong, or you did all the implementation by hand yourself, if you're using Unreal or I guess Unity as well, their replication system, you won't run into problems with bandwidth. Unless, as I say, you send some crazy things over the network, you replicate actual meshes across internet or something, you probably won't run into bandwidth problems. Maybe in some type of games, I don't really know, maybe in some type of games you would run into them. But in our case, and I think in most cases, what you do have to optimize is server CPU time. And this is for two reasons. One reason is what we talked about, right? If server starts to struggle, you immediately everybody on the server has higher ping, and you run into some very, very weird bugs because somebody starts using something, and then before that reaches server, the state on the server changes, it's completely desyncing, and it's a big problem. But the second equally important thing is that you literally pay for performance on the server. Because if you do a game that's poorly optimized on the GPU part, right? At the end of the day, it's going to be your players that will pay for it, right? They will have to buy more expensive GPUs, or the game will run slower. But when you are doing a multiplayer game, if you optimize CPU poorly on the server, it will cost you more. And it will cost you a lot more. Because when you choose a server that will run your game, you kind of choose as bad server as possible that can run your game at a constant, like pretty stable FPS. Because each next tier of servers that you pay for on the cloud or on premises is gonna cost you a lot more.
That's something I did not think about, like the infrastructure that's running that you need for the... What's the criteria for the cloud selection? Does it works the same as the usual cloud, that you just you pick a machine and you have like this amount of CPUs and this amount of RAM or things like that? Okay.
Yeah, for us, it of course it depends. If you are a huge company, huge corporation like Blizzard, for example, your servers are your own. Right?
Yeah.
You have a server room, you can pick precisely the architecture and the specs that you need. When you are a very small company and you are developing like an indie multiplayer game, maybe you also don't need any infrastructure, because then you can run peer-to-peer, especially co-op games. A lot of co-op games run peer-to-peer. So one player is the host, they run all the server code, and the other players just receive and send updates to them. But for games that are at least slightly competitive, like ours, we cannot really have one player running the whole server, right? Because they will have a huge advantage over everybody else. They will know everything that happens on the map, so they will also have access to, the location of every single rare resource that's there and things like that. So... in our case, the cloud is pretty much the only option that we have, right? Either cloud or investing a lot into infrastructure.
This should be your tagline. Providence, slightly competitive game.
Yeah. And fully answering your question, yes, we're using cloud, and yes, that's like you basically have a list of we're using AWS GameLift service, and you just have a list of different CPUs with different amount of vCPUs and different amount of RAM, and you just pick your poison.
What does it do, the game lift service? Because like on AWS you can rent just a virtual machine. In case of like game lift and game specific services, what does it do more than just grant you access to a machine?
It handles things like connecting to it. It opens ports. It's handling incoming traffic from the players. It has logic that you like. It's like a framework kinda library. I don't know how to call it, but it's basically game specific, right? So you can run some code when your game process starts, when it finishes. You can, for example, broadcast the server to some sort of matchmaking system. When your server crashes, it automatically restarts it. It has specific structure for logs, for crash logs, things like that. So it's basically just everything we would need to do ourselves if not for GameLift. All of this kind of around code.
Speaking of matchmaking, have you already, let's say, discussed in the company or thought about how do you want to pair people to play Providence?
Yeah. Yes. So also different parts of it, right? One part is just your team matchmaking. And I think either you have a team before you play, right? Or you basically join an existing server and you join a team that's already there. When it comes to matchmaking different teams, that's still under development. We are thinking about how much we want to have different tiers of sleep-ports, let's say, or different types of sleep-ports with different types of resources, more rare resources that are more dangerous, maybe things that are more like newbie friendly. Maybe some sleep-ports will only have PvE, they won't have PvP. This is something that we're still discussing, and probably we will have answers to those questions after playtests, after we slightly open to the public and people give us feedback about how they play, what they want from the game.
Okay, so now I'm really interested in the aspect of testing the game, because not only the game has a difficult loop to test, which takes time, and then you have the aspect of multiplayer, which adds another layer of complexity to all of this endeavor. So how do you approach now the testing, and how do you include the play tests and testing in the future to make it right?
Honestly, that's something that we are still very much working on. We have some tests that we are running, mostly just tests that gather the performance data. For example, I did one test where we spawn multiple players. We spawn a server on one machine, we spawn multiple clients on a different machine. This different machine connects to the server, and those are basically like bots that are running around and shooting in the air and jumping around. And then we get the performance report, right? And we see what's taking the most time and how the game performs. But we don't have like a full pipeline for this yet, because it's a very, very big task, right? We are still a I would say small sized company, maybe medium sized. And those are things that, for example, I know in games, networking games that are somewhat similar to us. Let's say Sea of Thieves, for example. They have a full department of software engineering in-test people, right? Who are working specifically on the framework for testing the game. so they have QA department and a whole software engineering department that just works on how the game should be tested and use it to, develop, like push updates frequently to the game and content. And we're not there yet. We don't have a full department for that. We don't have a full like this kind of QA pipeline. But what we are doing is playing the game a lot in the company. And this is also something I wanted to talk about, that playing the game for the first time was actually a very special event, because we had playtests before. We were playing the game sometimes with 4 people, 5 people, because the server couldn't really handle more at the time. We were testing different mechanics of the game, different specific moments, maybe a combat, maybe PvP combat, monster combat, harvesting resources, this kind of stuff. But earlier this year, there was basically a moment where few things came into fruition. The server was playable. It wasn't fully optimized yet, but the server performance was playable. We had 16 or 20 players join at the time, I think. And most importantly, we actually had a loop, like a full loop on Sleepworld. So all the teams landed on the planet. All the teams had an objective. The objective was shared, so people had to fight for one very specific resource that was coming from like a boss that was in the middle of the map. And all the people who were working on the game actually really played the game for the first time, right? So we all experience what it is actually that you are doing here, and oh shit, now I need to gather these resources, but I need to do it fast, because if I don't do it fast, other teams will be first to reach the boss and kill it and get it back, right? Then there was the whole part of hot potato, of fighting for this one resource in the middle of the map and trying to take it from each other and run back to your ship to depart and get this resource to your homestead. And yeah, like seeing this whole loop play out for the first time, seeing all the people get super competitive over it, and sharing screenshots at the end of people who won the game, it was very, very cool.
How long did it take to get to this point?
From like the beginning of development of the game.
I mean, I'm guessing that it would be difficult to establish like the start date of the development, but like roughly speaking, would in months, maybe, like with some range.
1.5 years, I would say, something around that, because our game was prototyped with just a few players, but at one point the game was completely different from what we have now, right? This gameplay, this loop is a product of, I think I would say, like last year and a half of work.
Yeah, that's also like regarding the testing. Like, if in order to test the Sleepworld with the current, let's say, gameplay idea, you need probably like 4 teams of 4 people, and they need to be like have stuff to do, not immediately see each other, for example, right? To discover themselves or not. Like you need a lot of stuff to get to the point where you can test this game. This is why I think it's a really nice endeavor, and it's really difficult, I'm guessing, for whole Dynasty to actually push through, because you need a lot of time to actually get to that point where you can showcase this stuff. And you say like 1 year and a half. Yeah.
And that's why our community is invaluable to us, right? Because people like at the conferences, or people who got the very early access, it wasn't early access, it was like a just barely playable build, already gave us a lot of feedback, right? And we are really taking this feedback into heart, because before that we didn't have this feedback, right? Because we were just playing internally in the company. We cannot just hire 20 people to play our game every day, right? And see how it plays out. And and that's also, I think, why early access in general is so popular recently, because it gives opportunity to companies who in other case wouldn't be able to develop this kind of games, right? Companies can say, okay, this is early access, this is what the game will be about. For now it's pretty bare bones, but please, if you want to play it and give us feedback, and we'll keep working on it. And if done properly, early access, not a huge company giving early access that you need to pay for the full price of the game to just play like a very early demo. That's not really a way to do it. But if done correctly, the early access can give this opportunity, which was not possible before.
Let's mention how one can become a part of the community, maybe.
Yeah, we have. You can just go to our webpage and playprovidence.io. I'm sure it's going to be linked somewhere in the podcast. And our main community is on Discord. We have a Discord server. Right now, it's around 5,000 people, but it's growing constantly, and it's pretty active. So you can join there, and we host some events, Q&As. We give sneak peeks of the gameplay there. Recently, we posted a sneak peek. It's hard to call it a sneak peek because it was literally like 20 minutes of gameplay of one of the internal play tests. But yeah, if you want to see how the game looks like, that's the best place to see. Or our Twitter account. We also post the content to our Twitter account.
Yeah, and I had a chance to play early playable versions as well, and it was really nice. Like it's a lot of fresh new ideas combined together, I think, and a lot of genres, aspects of different kind of game genres are blended together nicely, and you can do all sorts of cool stuff. Yeah, it's really unique and fresh thing. So I hope other people will also be able to play the game in some recent time, not too long.
Yeah, I hope so as well. Yeah, and I think that's what you said, right? It's a lot of things mixed together. It's not like we are reinventing the wheel. It's not like we have, not reinventing the wheel. It's not like we are, having something completely different from all the other games. We have mechanics and good parts of several games that we love to play. We have parts of Valheim, we have parts from Escape of Tarkov, we have parts from some sci-fi shooters, we have parts from Monster Hunter, for example, when it comes to boss fights. So we are taking inspiration from existing games, but the final product that we want to put out is something unique, or at least we think that it's something unique, that it's haven't been done before in that way that we are doing it, which I think is what is nice about making games, right? If you don't want to make something that was already made in a slightly different way, you want to offer something unique.
Yeah, and during the development, how do you collaborate within the team departments and technically, for example, with the project for the version control and just reusing the source code, both like the social aspects and the technical aspects of sharing the work?
So we use version control, of course. We use Perforce. I know that a lot of people coming from software engineering are surprised that game companies don't use Git, because Git is such a widespread thing. But Git doesn't offer some capabilities that are really, really needed in terms of making games. And it's basically handling big assets. I know Git has LFS, large file storage, but it's not working really well. And so storing big files and marking files as locked, let's say. So if an artist is working on a mesh, or a designer is working on some sort of a piece of blueprint, you don't want another person to, edit it at the same time, because you will run into conflicts that are not solvable. You can solve conflicts in source code, but you can't solve conflicts when it comes to binary blueprint files or binary assets. So that's the technical part. And then the workflow social part, it's a lot of different things, right? We're working in milestones, we're working in sprints. We have some deliverables for each team, and it's a mix process between like agile methodology, a bit of like more, not really a waterfall, but kind of a we know what we need to achieve in the next milestone. We try to break it down into sprints. We try to break it down into tasks, and then we work on it. We have producers, as any other game company, which is a role that also in software engineering is not so popular, right? You have project managers, you have managers, you have scrum masters, you have product managers, but producer is something unique to gaming, I think, because producer is a person who kind of keeps a big overview and also keeps in touch with all the details of things that are there, right? So producer needs to both know a bit of, maybe not coding, but at least how the coding workflow works, how art works, how how design works, and then kind of try to stitch it all together, right? And make it so designers can work with programmers in an efficient manner, artists can work with everybody in an efficient manner, nobody waits for somebody else for weeks or things like that.
So it's like a combined role of both Scrum Master, kind of project manager, with a deep knowledge of what is happening and who is doing what, right?
Yeah, exactly. Yes. And as a software engineer, you can kind of organize your own work, but in game development, it's possible to an extent, depend on what you're working on, but you won't know the full scope of stuff that is happening, right? Like as a programmer, I don't know what will be the next art asset that will be produced, but maybe it will be needed, right? Maybe my next task actually requires getting something very specific from art. And if I were to take care of that and, talk with some people and ask them for things to be done, that wouldn't really work. So yeah, there needs to be a person overseeing this process.
Okay. I have one general question regarding the work you've done on Providence so far. Do you have things that you have learned that you can share based on your experience working on Providence, both in the networking part, but in general, in the larger part of the let's say medium game development company, but on larger project?
Mm-hmm. About just in general, like things I learned.
I think I'm interested in the technical parts. So, for example, how do you approach the project that is large? How do you now? What's changed after, let's say, for your workflow, your personal habits? How do you approach things after some time working?
Yeah. Well, one thing technical that came to my mind is how I approach working with Unreal Engine, because it's a very different engine than Unity that I was working in before. And of course, working in game engine is much different, very, very much different than working just in like a programming language, right? So Unreal already has an established game framework, and you can't escape it. You can't work outside of this game framework. So in Unity, for example, you kind of decide yourself what you want to do, right? You say, okay, I will have a game manager, which will do that. And I will have a character, which will do this. And I will have a character manager, maybe, which will take care of characters and do something with them. In Unreal Engine, it's already there, and it's already done for you. And things exist that have very specific roles in your game. And if you try to break it, if you try to not use those things but some other things, it will end really bad for you. So there's a game mode, and game mode exists only on the server. And game mode takes care of, initializing some stuff on the server and taking care of how everything works when it comes to like a game specific things. But you also have a game state. The game state is replicated to the players. And in game state, you keep stuff like, I don't know, the teams and who is in specific team. And then you have player, character, and then you have player state, and then you have a player controller. And each of these things does a very specific piece of work. So if you want to implement a feature, first thing that you think about is, okay, where should it reside? Who should know about it? Is it a part of player character? Is it like a component that I will add to player state, for example? Is it a thing that, I will just implement completely separately as an actor? And then after you start thinking about it, one more thing that you should check is maybe Unreal already has it. Because many times we just discovered like a random checkbox somewhere that was actually doing exactly what we wanted. And instead of doing a whole system, you just needed to check this one checkbox and everything would happen automatically. And this, for example, I was working on rejoin system, right? And I did a rejoin system by myself because I did notice something that was going around in the engine when it comes to storing player states of people who disconnect from the game. But I was like, no, this can't be it, right? So I will do it myself. And I did the whole rejoin system. And then it's been just a source of constant problems because it turned out that Unreal Engine already does it. When you leave the game, it stores your player state. It makes it inactive. It, it copies it. It does some weird magic behind the scenes. But if you want to make a rejoin system, you should use what's already there and then only, bit atop of it, maybe save some very specific data that you need to save. And what we have right now that we need to work really hard to undo, kinda, is a rejoin that I made, rejoin from Unreal Engine, and then they really fight against each other on, in who will take control of like destroying the player state, for example, right? Or storing data from the player state. And that's not really great.
I like that in the end, after in the majority of the podcast episode, complaining about Unreal quirks and different issues, we've managed to come up with something positive about Unreal and say like, Unreal sometimes have a lot of cool features. You need to find them, but they are there.
No, Unreal is great, but it's a beast, right? It's trying to do so many things at the same time, and you need to really be careful of what you use and what you don't use. Because also that's a thing, right? Unity was meant as a game engine. Unreal was not made to be a universal game engine. Unreal is still an engine for a first-person shooter. And the core of the engine still is meant to be an engine for first-person shooter with a very specific things. And then, of course, they generalize it a lot and made it possible to make any type of game inside of Unreal Engine, which is great. But some things, like, for example, player state, right? It's literally, you need to store your kills, assists, and deaths and, be able to check them from other players, right? And the reason why there is player state, why it's replicated to all the players is, of course, you need to know, like, how many kills you have and how many kills other players have. And then you kind of try to wiggle around your way into using that for your own features and implementations.
Okay. Any final thoughts and mentions?
I think when it comes to Unreal is that I wholeheartedly recommend using it despite everything that we said and talked about. It's a brilliant tool, and people who wouldn't be able to make games are making games and are making really good games and showing it to the world. I think it's the same with Unity, right? Both of them are good, maybe in different ways, but when you start working in it, you don't have to be scared of all the replication stuff and the deep technicalities that we mentioned. on the surface, you can basically just get a blueprint, open a blueprint. You don't even have to open C++ class. You just throw in a couple of things and it works and it's great.
Okay. Then I need to maybe come back to Unreal Engine. I was trying to learn this, but as you mentioned, like you need to learn the whole framework first. It's not the same.
Mm-hmm.
It's not like a bare bone thing. It's already have some predefined things. Okay. Thank you then for your conversation and for your time. For all the people listening, remember to check out playprovidence.io and the Discord server. And we will wait for the more information about the future release.
Yeah, I hope we all get to play it sooner than later, as you said.
Thank you so much. Take care.
Thank you.